Chemical demonstration of water-reactive materials, lithium and sodium metals. Chemicals regulated by the U.S. Department of Transportation as dangerous when wet are considered to be a major risk to responders. Dangerous when wet belongs to the hazard class 4. This class is further divided into 3 divisions. The examples we will demonstrate in this video are lithium and sodium metal. These chemicals are classified as Hazard Class Division 4.3. The U.S. Department of Transportation requires that any amount or quantity of this type of material transported by highway or rail to be placarded regardless of weight or volume. As the wording or symbol on the placard implies, the definition of this hazard class and division is any material that when contacted with water is most likely going to become spontaneously flammable or give off flammable or toxic gas. First, we will react lithium metal with water. This chemical reaction will produce 3 things: flammable hydrogen gas, heat, and lithium hydroxide as the residue left in the pan. Since we are using thick cuts of lithium, it will not react fast enough to generate sufficient heat to ignite, but if a spark were to be present, the hydrogen gas would ignite. The thin cut lithium from batteries will spontaneously ignite when exposed to water. Once the reaction is complete, we will use pH paper to test the residue, and we will neutralize this strong base with vinegar, a weak acid. The lithium and the sodium that we will use in this video are so reactive to water, even the moisture in the air may be enough to generate decomposition and fire. To prevent this from occurring, these metals are kept in oil to keep them dry during storage and transportation. The residue of lithium hydroxide left in the pan rates a 13 to 14 on the pH scale, which is considered to be a strong base, as indicated by the dark blue color change on the pH paper. Now we are using vinegar as our weak acid to neutralize the basic residue. In a perfect world, we would like to get it to a pH of 7 on the pH scale, but we'll settle for anything between a pH of 5 and 9. Lithium and sodium are very similar since they are both in the same family of water-reactive metals, but sodium is considerably more dangerous since it reacts faster with the water. This reaction will produce heat, hydrogen gas, and sodium hydroxide residue, another strong base. In conclusion, in this video we have demonstrated that chemicals regulated as Hazard Class Division 4.3 should be considered extremely hazardous and should not be allowed to contact water. The outcome of this type of reaction will produce heat, a dangerous gas, and possibly dangerous residues that may be overlooked by responders.